Okay, so today we are going to talk about real-world learning through data probes, and that's the experiment we did in class, or the station that we did in class, where we had those multiple tools to measure different things in the environment. I chose the one that was related to the weather, so we went around, me and my group went around and experimented with the relative humidity in different areas of the building and outside as well. It was that day where it was, I think, like 46 or something with humidity. So we kind of wanted to see what that would look like. Okay, is it less humid by running water? Is it not less humid by running water? Inside, outside, different areas, downstairs, upstairs, things like that. So I want to go through the questions here with you. The first question in regards to connecting with the curriculum in the real world, right? How does an activity like this make an abstract scientific concept like thermal energy, photosynthesis, pH scale, tangible and relevant to students? Well, I just really think that it shows us how these abstract concepts exist in the real world around us every day, right? They take these abstract concepts and put them into our real life, right? Okay, what is humidity? Where is it? How can I tell where it is? Okay, well, now I can tell that it's much more humid outside on a day like today than it is inside, right? I can see that difference. I can, maybe test out the pH in different things, right? And try to kind of put that abstract concept or attach it anyway to something that is tangible, something that is kind of real and that we can see in our lives. Um, Next question, describe how you could design a similar real-world experiment for a specific unit in your own curriculum. Um, I think there's lots of ways you can do this. It really depends on what the syllabus or the unit that you're doing is, what you're trying to achieve. You could have students examine weather patterns over a period of time, try to notice some trends. You could also have students measure various factors on a kind of progressing forest area. Say somewhere where a forest progresses to a somewhere that's more barren. So say, for example, you have a set of cliffs in Nova Scotia, or a forest near a set of cliffs, and as you get closer, the trees get less big, they start to turn to shrubs, they get smaller and smaller until there's not really very much growth at all, right? So we could have the students go there and try to figure out, okay, why is that happening? What can we measure? What can we take from the soil, from the air, the wind? I guess that is part of the air, right? But all those various environmental factors, and can we try to figure out why that actually happens? There's a million different ways I can think of to use this. That's one that comes to mind. So we'll jump to part two here. And part two is fostering authentic inquiry. Question is, how did the process of designing and conducting your own experiment differ from a traditional prepackaged lab activity? I think this just really allows your own creativity, allows your participation, it allows you to kind of try and form those hypotheses and analyze it, right? Come up with a question. We talked a lot in our other classes and in this class too about question-based learning, right? And when we give students the tools to say, okay, what do you want to know? Here are some tools. What can we try to figure out? What questions do you have? And how can you test that, right? We're building them up for skills that they're going to need to use in the real world, right? To learn how to ask questions, think about how they can find the answer to those questions, and then go out and try to find those answers and see what they get. We'll move on to the next one here. In what ways does real-time data visualization empower students to make predictions, analyze results, draw conclusions on their own? I think it allows them to ask questions about their environment and try to, hypothesize what they might need to prove their hypothesis, right? It allows them to kind of see in real time, okay, I am outside and it is, really humid outside, more so than inside. So I know that for a fact. Maybe knowing that, I'm going to test somewhere else because of that, right? Maybe if the answer was different, I would go to a different area, right? So rather than kind of taking those results, processing them in a way that isn't real time, that might take, a little bit of time. You have to go back to a lab, you have to, you know, run it through a computer program, and then you realize you didn't really get what you want. So then you pivot and you have to try again and repeat the process, right? So by giving that real-time data, I think it just allows us to have that kind of immediate, is this working? Right? Where should I go next? Right? Can I follow the plan that I had? Is that really setting out to prove that what I'm thinking, or based on what I'm seeing, am I going to change routes here? So number three, problem solving and data literacy. So the question here is, this activity is about using information from our surroundings to make better decisions. How does this process model the kind of data informed problem solving students the kind of data informed problem solving that students will need in the future? Again, I know I've said this already, but I really think just being able to formulate something that's testable, a hypothesis, right? This is my idea. How can I go out and test that? Being strategic in how they collect the data, right? What am I going to do to collect that? How can I form a strategy to prove the point that I'm trying to prove, or see if it is provable, right? See if I was right. Understanding, I think, tools and technology a little bit plays into it as well, right? This kind of activity, it has us look at this and say, okay, this is what we actually use to measure these abstract concepts, right? And this is how these abstract concepts seem to act in the environment that's around me. Then we have to look at the data. We have to say, okay, what does this actually tell us? Is this proving what we want, right? Is this not proving what we want? We got to look at it. We got to interpret it. um, I think, overall, it's just building those problem-solving skills that are really, great, and will be applicable in the real world as well. So, how does this build a foundational literacy in understanding and interpreting data? I think, by letting them do all the things above, right? But letting them above, I mean, I'm looking at some notes on a Word document, but above meaning the things that I've talked about before. By letting them do everything that we talked about, the problem solving, the question posing, the analyzing the data, right? And allowing them to make mistakes and then learn from those mistakes, right? We are getting our students to collect data, look at it, see if it matches the question that they ask, see if it proves anything. And, that is really going to build that foundation and literacy in understanding and interpreting data, right? By the process of working with data to try to answer the questions that you have. For classroom implementation, what are the opportunities for using these tools to foster collaborative, inquiry-based learning in your classroom? So 100% with the inquiry based, right? I think we're asking questions. They're required to formulate a hypothesis. They have to collect, analyze data using the tools, interpret their finding, and that really, I think, sort of directly mirrors the data informed problem solving that is crucial in future careers, right? Kids these days, people in general these days, need to know how to ask questions, how to look for the answer, how to solve them. It teaches them to be strategic in gathering information from their surroundings and to make decisions, right, on what's valuable and what's not. I think that's a really valuable skill that you need in the world today, especially where everything is kind of becoming a little bit more data oriented. What are some practical challenges and how might you address them? So I think time is a huge factor. I think it takes time to set up a lesson plan where students could include something like this, and then figure out how we're going to grade it, what limitations, if any, we're going to put on it for our students. The solution for that would just be planning ahead, right? And reusing the material for your next years as long as it's still relevant and applicable. Um, Resources, right? I think that's a huge one. Access to the tools could be another one. Access to the space needed. Maybe if you want to test what I was talking about earlier, where why do the, trees tend to stop and the growth gets significantly less as we get towards the edge of a cliff, right? We want to test that out. How are we going to do that, right? Maybe there's safety concerns. Maybe we can't get a bus to take these kids to that area. I think a solution, at least for the resources, is to just put in, the request that's needed to get the material. I assume the classrooms won't just have those measuring tools in them. So if you need to request the material, do it at the same time and as other teachers and partner with other science teachers, geography teachers, whatever it may be, and do lessons that use the same tools at the same time while they're at your school. Right. And potentially, if you both know that you want to examine something in the forest, maybe you can kind of do a joint trip together. Right. And then, with that kind of safety aspect, I think, obviously, maybe if you know it's not age appropriate and, things can get dangerous, don't do anything too close to a cliff, right? I'll just say that. But kids could also kind of get crazy if you just let them run rampant. I wouldn't do something like we did in our university classroom where, the prof just stayed inside. I guess you watching this, and I wouldn't just stay inside. I would kind of go out with the students, especially if they're younger. If they were younger, I'd kind of confine them to maybe a specific area, make sure that it is a safe area. I think kids could skip class as well. I think that's definitely a possibility. Thinking back to my high school days, if you just kind of let them go. But I think just kind of keeping an eye on them and asking for support if you need it, right? Maybe again going back to that other partnering with other science teachers, maybe you can, help them out on your off period if you do have the time and the resources to that, and they can return that favor for you if that's a necessary step for what you're trying to experiment. So yeah, those are my thoughts there.